everyone, it's Mrs. Summer here to talk about lesson 903, Congruent Polygons. In this lesson, students will be able to write congruence statements. They can write congruent polygons in corresponding order and can find the side lengths and angles given congruent polygons. If you remember that two geometric figures are congruent if and only if a rigid motion or composition of rigid motion maps one or of the figures onto the other. A rigid motion maps each part of a figure to a corresponding part of its image. Because rigid motion preserves length and angle measure, corresponding parts of congruent figures are congruent. In congruent polygons, this means that corresponding sides and corresponding angles are congruent. What that statement means is that if we were to apply our rigid transformation, so a translation, a reflection, or a rotation to one of the image, and you can make it superimpose it over the pre-image, then they are congruent. So in this example, so when triangle DEF in the image, when DEF is the image of triangle ABC, after a rigid motion or composition of rigid motions, you can write congruent statements for the corresponding angles and corresponding sides. So in this case, corresponding angles, so angle A here and angle D here are congruent, meaning they are equal. Angle B is congruent to angle E. Angle C is congruent to angle F. And the corresponding sides, so length AB is congruent or equal to DE. Length BC is equal to EF, and AC is equal to DF. So in this example, it says to write a congruent statement for the triangles and identify all parts of the congruent corresponding parts. So if we first look at the angles, so angle L is congruent to angle R. Angle J is congruent to, let me make that congruent symbol better, congruent to angle T, and angle K is congruent to angle S. Now if we look at side, so length JK is congruent to length S side ST. Length KL is congruent to SR, and then length JL is congruent to RT. So now we're using the properties of congruent figures to solve for for variables. So in part A, it says find the value of x. So here. So first we have to figure out what part of this polygon here is congruent to that part. Now if you look at it, if you just flipped this triangle, like you reflected it, it would match that triangle. So for A, you have QR is congruent to GF. So 2x minus 4 is equal to 12. So 2x is equal to 16, x is equal to 8. And then for B, it asks to find the value of y. So if we know that RQ is the same as, or QR is the same as GT, we also know that this angle here is equal to 68, because this is actually a reflection over the x and a reflection over the y axes. And so this angle is actually that angle. So if we go and we get 6y plus, we determined x was 8, is equal to 68. 6y is equal to 60, y is equal to 10. So now you try in diagram ABGH is congruent to CDEF. So that means that A and C are congruent, B and D are congruent, G and E are congruent, and H and F are congruent. So find the value of X. So you try. Find the value of X. Okay, to find the value of X, we have 4X plus 5. So if we just rotate this figure, our figures will match up. And so if we rotate it, we have H and F are the same. And so we're going to equal 105. So 4X is equal to 100. X is equal to 25. So in the third angle theorem, if two angles of one triangle are congruent to two angles of another triangle, the third angle is also congruent. So it kind of is a duh statement. If this angle is congruent to that angle, and this angle is congruent to that angle, inside of a triangle, this angle has to be the same as that angle. So in this example, it says to use the third angle theorem to find M, the measure of angle B, D, and C, BDC. So B, D, C. So we want to find the measure of that angle. Okay, we need to start by writing down what we know. We know that angle A is equal to 45 degrees, which is congruent to angle B. So we know that angle B is equal to 45 degrees. We also know that angle C is 35 degrees. I'm not 35, it is 30 degrees. And because it is congruent to angle CDN. So angle C in the triangle BDC, we know that triangle C here and triangle B are already accounted for. So now we know, using the triangle sum theorem, that 45 degrees plus 30 degrees is equal to, plus angle D is equal to 180. So we have 75 plus angle D is equal to 180. Angle D is equal to 105 degrees.